Hello, I'm George Malim, the Managing Editor of IoT Now, and welcome to today's webinar, the topic of which is the top 3 best practices for a secured IoT solution at global scale. With the arrival of low bandwidth cellular technologies such as LTE, Cat-M, and narrowband IoT, we now have connectivity options for IoT that offer both low cost and power efficient capabilities. These are important in opening up IoT to new business cases that previously would not have been viable, either due to power consumption or to the costs of traditional cellular or even satellite networks. However, just because connectivity is now available more cost effectively and with the potential to consume less power and therefore have longer device life, it doesn't mean that connectivity has become simple. There is much to consider in general when it comes to IoT connectivity, and even more to take into account once network selections have been made. This webinar will take a deeper look at 3 key security and operational challenges involved in the rollout of LTE-M. First, we'll look at device identity to dispel common misconceptions about device credentials. Next, we'll explore data access security and assess how you can prevent data leaks. Finally, we'll lift the lid on how to manage remote updates and explain the challenges and techniques for managing these at scale in constrained bandwidth environments. I'm delighted to welcome today's speakers, Evan Whitlock, a product manager at Aeris, and Robin Duke-Woolley, an analyst and CEO at Beecham Research. They'll also be joined by Amit Ketawat, the head of products at Aeris, who will help the panel during the Q&A session at the end. I'm delighted that all of our speakers will stay on after the presentations to answer questions from the floor. Simply use the panel on your screen to ask a question, and I will put it to our speakers. Now, without further ado, it gives me great pleasure to hand over to Robin Duke-Woolley from Beecham Research. Robin, the floor is yours.
Thanks very much, George. So I'm going to just say a few words about securing cellular enterprise IoT solutions before Evan then talks about the 3 different techniques in much more detail. Before I start, I'd just like to make people aware that there is a light report which is going to be available straight after this webinar, covering the detail in this webinar. So look out for that. So my first slide really just draws attention to the rapid growth rate of IoT. These slides are focused on cellular, but of course the overall market covers connectivity for Wi-Fi and Bluetooth and fixed line and all sorts of other forms of connectivity as well. But even when just looking at cellular, we're talking about a growth rate of nearly 34% per annum over the next few years, split down with traditional cellular being about 20% and low power wide area being much higher than that. I think Evan is going to talk about the low power wide area elements for cellular in more detail and the opportunities there and impact there. But of course, with this sort of high growth rate, we're talking about the opportunities for security breaches are also growing accordingly. So then talk about the threats. So there are many threats, and we've probably we've all read the papers, so we know what's been going on. There are many cyber attacks being reported in various IoT sectors, including attacks on critical infrastructure. By critical infrastructure, we mean things like banks, telecom companies, industrial companies of various sorts, utilities, and also not often mentioned, there is food processing and transport sector as well. So those things are going on and they're increasing, and that's impacting on activities in IoT. That's very much in the sort of business to business area, but in the consumer space there are examples as well. We've had the example of the Mirai botnet attack, and that was the largest ever distributed denial of service attack. It attacked DNS servers, bringing down a number of major internet sites in the US and Europe. And it was launched from connected consumer IoT devices, taking those over and then having a mass attack on these internet sites. So it took over CCTVs and digital video recorders and lots of other stuff as well. So that kind of stuff is going on, and clearly that's an economic issue as well as an operational issue for people. So it needs to be addressed. And in addition, there are many instances of individual consumer devices being hacked. There's a famous one now of the baby monitor being hijacked and turned into a broadcast device. So there's a lot that needs to be done. Now there's been ways of looking at devices in the past. They tend to have been fairly after the case type things, sort of added on afterwards. But there's much more of a need now to look at things built in. And Evan is going to talk us through much more of that. But here's some pointers towards where this is going. Finally, legislation is beginning to catch up with this, and in the US, state and federal authorities are now initiated IoT security legislation, and compliance to be an important factor in the IoT device and network design implementation. So building it in from the start rather than as an afterthought. Just to take an example of that, we've got California's SB 327 bill, which goes beyond existing law focused on consumer privacy. And I'm just quoting directly from the detail in that. So it's beginning on January the 1st, 2020, and it requires the manufacturer of connected devices to equip the device with a reasonable security feature or features that are appropriate to the nature and function of the device, appropriate to the information it may collect, contain, or transmit, and designed to protect the device and any information contained therein from unauthorized access, destruction, use, modification, or disclosure as specified. Now, that's deliberately left quite open, so it needs to be interpreted and it needs to be thought about, but it is potentially pretty wide-ranging in its impact on manufacturers, and we'll talk about that, I think, a little bit more in the Q&A session. But then moving over to the federal level, there's an IoT Security Act that was passed in March this year, and the purpose of that is to leverage federal government procurement power to encourage increased cybersecurity for Internet of Things devices and for other purposes. So the NIST, the National Institute for Standards and Technology, will be in charge of executing the provisions of the Act, making sure that it's enabled and takes effect. But the real thing that they're anticipating is that government agencies will be prohibited from acquiring non-compliant devices, and obviously government procurement in the US is a very high proportion of the market. It's obviously not the whole of the market, but it represents a significant amount of the market that manufacturers will be encouraged to conform with that for all of their products. Otherwise, they'll find that they can't get into that type of product at all. And then in Europe, we have GDPR, privacy regulations, in 2016, not directly related to IoT, but tangentially, certainly. So that's where data collection of personal data and consent are involved. And of course, the fines in that are quite considerable if you don't get that right. EU new Cybersecurity Act in March 2019 that creates EU cybersecurity certification framework focused on the transparency for cybersecurity assurances of IoT products, services, and processes based on existing standards. And then there's extensive critical infrastructure regulations already in place. So, that's just a few slides that indicates legislation is coming along, and it's important to get that right. And it's important also for manufacturers and suppliers in the IoT space now to start thinking about the implications of the legislation and where that's going in the design of their products. So I'm now going to hand over to Evan, who's going to take us through the rest of the presentation. Over to you, Evan.
Thank you very much, Robin, and thank you for that great introduction to kind of set the stage of what we're talking about today, which is these risks and new legislations that are forcing IoT solution builders to pay far more attention to security and how to build more secure solutions, and really forcing that issue to the forefront of solution developers' minds. And so before we jump in, I do just want to give a quick introduction to Aeris. For those of you who don't know about us, kind of explain a little bit why I'm here talking to you guys today. We are an IoT solutions provider for the context of today, focusing specifically on providing intelligent IoT cellular networks and cellular networks designed and altered specifically for IoT solutions as opposed to consumer handsets, which we've been doing for the better part of the last 20 years. Today, we actually manage over 13 million units globally. Our headquarters are in San Jose, California, and we take that Silicon Valley mindset of innovation and apply that to IoT networks and IoT solutions that we build. As a company, we're actually heavily on the engineering and operations side, with over 60% of our employees focus on building out and maintaining these innovative solutions for IoT and IoT solution builders. So this is something we've been doing for a while, especially around the cellular side, and something that over the years we've seen a lot of different solutions and have developed a set of best practices that we want to share with you today. So with that out of the way, let's jump into the agenda for today. So one of the things we want to talk about is some of the threats and drivers around the topic of security for IoT deployments, and Robin did a great job of setting the stage as to what some of those threats and drivers are. I'll touch on a couple more of those and really get into what is pushing people building IoT solutions to now focus on security in a bigger way than maybe they have in the past. The other thing we're going to take a look at is what some of your options are, what some of the traditional options are to address some of the key security categories. And then finally take a look at what some of our recommendations are and some of the solutions that we've built to address some of these concerns. But before we dive in, I believe right now we have our first poll question. So with that, I'm going to pass it over to George to talk through the first poll question.
Hi, thanks, Evan. Great. Here's the first of our polls today. The question is, how many units do you have deployed or under management today? And the options are more than 100,000, 50,000 to 100,000, 10,000 to 50,000, less than 10,000, or none. So I'll read the question again. How many units do you have deployed or under management today? And while we're waiting for the poll to settle down, I just emphasize that we have our speakers today ready to answer your questions. We've had some questions come in already, but do feel free to post your question in the Q&A box, and I'll put it to the panel at the end. I think the numbers have settled down now, and I guess pretty much as expected at this stage of the industry, the majority of respondents have fewer than 10,000 units deployed or under management today. However, I think it's very interesting that almost a quarter have more than 100,000 units deployed or under management today. I think that's a very encouraging figure, demonstrating that there are some really large volume deployments starting to happen. So I think that's interesting. Evan, do you have any observations on that outcome?
No, I agree with your thoughts and think it's interesting. Obviously security is going to apply to everybody, and the fact that we have people checking in across the board, I think speaks to that a little bit. Interesting as well that we have the majority of people looking like they are starting to think about their deployment, building from zero, or looking to scale into the tens of thousands. I think that the scalability aspect of security is obviously a very, very important feature, and something that really needs to get figured out before you're before you're going to be allowed to scale to that size and manage it efficiently. So I think that's a great set of figures to look at, and I think that's going to correlate directly with what we're talking about coming up.
Okay, great, Evan. I think we'll hand back to you to keep progress going through the presentations.
Great, thank you. All right. Well, then jumping right in. So there's going to be kind of three buckets of security related topics we're going to talk about. And the first one that is a major risk for especially for IoT devices around device identity vulnerability. How solution builders are able to authenticate that the device that's communicating back to their system is in fact the device that is supposed to be communicating. Especially given that there is not, in most cases, a human on the other end of it to validate or to confirm that that is the correct device that's supposed to be talking, or if you need to send something down, validate that that is the correct device. Previously we'll talk through some of the options on this one, but using username and password, some of the legislation is preventing basic passwords, admin, for example, from being used to validate device identity. And it's a big hole right now for a lot of IoT solutions. How do they verify that the devices that are communicating back to them are the correct devices and are authorized to be communicating on that system? The next is when we look at the actual underlying data that's being sent from that device. How do we take a look at and protect that underlying data? Obviously, depending on the different types of solution, that data can be extremely important to protect. For example, whether it's a medical solution and it's patient privacy information that's there, whether it's a financial solution or a point of sale solution, and that's banking information or financial information that's being sent. But also making sure that devices of any kind are protected from being used as a weapon, preventing data to being sent to any other third-party site or any other part of the internet where it can actually be used maliciously, like in the Mirai botnet attack, or information that a device is generating being sent to somewhere that it's not supposed to, whether it will be stolen or used inappropriately or whatever it might be. Protecting that data is another point of vulnerability here. Then the third bucket that we're going to talk about is, obviously with a connected solution, that implies that then things can be changed and updated remotely. And so solutions now need to have what we're calling zero-day vulnerability, where if there is a breach, what can you do to fix that immediately and be down for 0 days effectively? It's a large challenge, especially when we get to the low bandwidth networks, LTE-M and so forth, that many IoT solutions are looking at. How can you update a device efficiently, effectively, and get that security breach fixed? Is a big part of the new legislations coming out, which we'll see, and figuring out how to most efficiently manage those updates is very, very important as part of the end-to-end security design. So those are kind of the three buckets that we're going to look at. But before we do, let's take a look at why some of these things have come to the forefront in today's the sensitivity around security in the IoT world. So first it starts with the fact that by and large security has been an afterthought for companies building IoT solutions, the solution builders of the world, and largely because it was viewed as a potentially unnecessary cost. And historically, a lot of solution providers, whether they wanted to get to market faster or keep their initial costs as low as possible to get launched, they've cut corners around security, thinking that this probably won't become an issue down the road, and thinking who is ultimately going to try to hack these closed circuit cameras and so forth. Furthermore, there haven't been a whole lot of regulations historically to force solution builders to do something about this, and part of the reason why I'm sure that many felt a bit more comfortable with cutting some of those corners is because there wasn't anybody telling them or encouraging them to be proactive about that. Now that has resulted in a lot of solutions that have been deployed that are not secure today, and when exposed can cause a whole lot of problems. In that Mirai botnet example that Robin walked us through is obviously one of the more infamous examples, but a great example of what could potentially happen. Because these devices were not secure, because the data was not secure, because they could be used as a weapon, they were used as a weapon, taking down most of the largest sites on the internet. And so without having those security measures in place to begin with, results in a scenario where lots of solutions out there are not as secure as they need to be. The result then that has made an impact to the solution builders and those building IoT solutions is the fact that the industry is responding, not just with companies coming out with best practices and calling out shedding more light on the potential risks of an unsecure solution. But the governments and standards bodies are now starting to take a much more proactive role around security for IoT, as we've seen with the California SB 327 law. But also, that's just one example. Many states in the United States are already doing the same thing. We've seen other measures in Europe, GDPR, for example, and others that are coming through. And so what we're starting to see is a very large trend from the regulatory bodies, from the government, to push tighter regulations and tighter punishments on security around IoT deployments. And what that's really meant, and it looks like I apologize, I'm having a connection issue with my computer. I'm not sure if George or Robin, could you advance to the next slide?
Yeah, I can advance the slide for you.
Yeah, great.
Sorry about that.
Keep talking through it if that's perfect.
Is that okay?
Great. Thank you very much. Yeah, that looks like it's popped up. Great. So, ultimately what all of this has led to, and especially the government regulatory body stepping in, is that IoT's, security is no longer something that can be ignored, something that can be cut, something that can be forgotten about. IoT solution builders no longer have a choice. They have to go invest in making a secure solution. They have to invest up front to address these three key areas. Otherwise, they could face very, very serious and very harmful ramifications down the line, whether it be punishments from the government or severe impacts to the brand. In the Mirai botnet example, the camera company is no longer in business. That attack was large enough and impacted their brand to the point where they closed their doors. They had to shut down. So security is no longer something that you can decide to not do something about. You have to invest. You have to figure it out. You have to come up with ways to create a secure solution. And so with that, what we're going to do, I believe we have one more poll question before we jump into the options and solutions.
Yeah, that's right, Evan.
Yep, let's go ahead and get to that next poll, George.
And here's the question. Which of these security topics have you addressed or tried to address? And the options are device identity, data access, zero-day management, all or none. And I should qualify the all option. That's if you've had maybe two of the three: device identity, data access, or zero-day management to consider. So again, I'll repeat the question, which is, which of these security topics have you already addressed or tried to address? And the options are device identity, data access, zero-day management, all, which could be two of the above three, or none. And while we're waiting for that to settle down, I'll just issue a reminder to send in your questions for me to put to the panel at the end. We've already got quite a few coming in, but I think there'll be time to answer a few more, so it would be well worth putting forward your question. And if we don't have enough time, we'll answer those offline after the live event anyway. Great. I think we're settling down, and the topic that most people have already addressed or tried to address is data access. Encouraging, that's followed by people who have selected all, with just over a quarter of our respondents have done at least two of the three, maybe all three of the topics. Evan, that's quite interesting. I'm not surprised really that data access is the one that people have addressed first. I guess it shows the significance, I guess, and understanding of the issues that a large proportion, 26% of our respondents have already addressed or tried to address the three topics. I guess zero-day management potentially lags behind, but maybe it's just not being separated out. What are your views, Evan?
Yeah, no, I agree. I think that this is pretty spot on in terms of my expectations of the response. I expected to see data access as the leader in this one. Certainly, protecting the underlying data is probably what the initial thought is when thinking about securing a solution. And I think as some of the things, the examples we just talked about previously, and some of the new regulations are forcing more thoughts around the other aspects like device identity. I'm sure that more people have addressed the zero-day management, especially in that catch-all category. But a healthy mix and something I'm not surprised by.
Okay, great, Evan. Let's close the poll and we'll move on.
Great. So then jumping in, what we'll do is we'll take a look at the first bucket, device identity vulnerability. And what we're going to do, how this will be structured for all three is to talk about what some of the options have been historically to get some of these, to get solutions around device identity vulnerability. And so one of the more common options out there is using symmetric keys, user ID passwords, multi-factor authentication, whether they be shared keys or unique keys to authenticate the device with the back end, whether it be in the cloud or the back end server and so forth. This is an attractive option for so many, largely because of the relatively low upfront development effort and cost. It doesn't take a lot of development, a large team, or a high dollar amount to get set up with these symmetric keys. So because of that, and because it is a pretty scalable solution, especially in terms of a lack of needing to manage this for a large number of devices over time, once you get those out there with these keys, they're pretty set. The problem is that they are very highly vulnerable. The reality is that both these keys are going to exist, one at the device and one at the back end. And if either one of those is compromised, that means that the device is in compromise and the solution is in compromise. And so it is ultimately something that should be met with great caution, an option that should be met with great caution because of the fact that those keys are so vulnerable, even though it comes with a low price tag up front. The second option that a lot of companies have considered are security certificates. These are more secure, certainly, than keys and customizable, get exactly what type of certificate you need, and it fits with pretty much all types of devices and solutions. A lot of different vendors that provide them make it relatively easy to do. The problem is when we look at the maintenance effort and cost of these certificates, managing the expiration dates, the renewals, tracking which devices have the certificates that are acceptable, which ones have been expired, replacing the certificates, renewing the certificates. It is not an easy thing to manage over time, especially when you're scaling into the tens, hundreds of thousands of devices and higher. So while secure, it does present a difficult maintenance challenge over time. That we would recommend you take a very strong look at to see if those maintenance challenges are something that work for you or not. Then the third option that a lot of companies are looking at are using trusted platform modules, whether it be a new piece of hardware that gets added onto their device or part of an existing hardware supplier. Now, the good thing here is that there are a lot of off-the-shelf options, a lot of different, hardware manufacturers that provide some sort of built-in security into the devices themselves. Additional benefit is they can get pre-configured with cloud credentials. So when we look at then activating devices, both from a connectivity, a device, and a back-end cloud service standpoint, it can make it easier to do that in scale, make it easier as you're rolling devices off the manufacturing line. The challenge with these platform modules is that it requires a great deal of expertise on your side, and it will require resources in-house to implement, manage, and make sure that these things get set up correctly. There could also be, depending on which type of hardware that is introduced as part of this, a need to redesign your existing hardware, make room on your board, make room in your box, whatever it might be, to accommodate this new hardware add-on. And so while it does provide a secure device authentication, it can come with some challenges, especially around the hardware side with this model. So a couple different options that are on the table to consider, and one more option that we will put on the table for you is what we've done with creating a secure SIM element as as part of the solution that we call zero-touch provisioning. At a high level, what we've done is we've taken, as a cellular network connectivity provider, we obviously provide SIM cards to all of our customers who are connecting on our networks. And so we have a new secure SIM that's preloaded with a secure element that will automatically authenticate that device's network access, and even tie in back into the back-end cloud architecture and infrastructure to validate that device and confirm that it is an acceptable device. And so this is one of the ways that we that we go about providing device identity management. Now, there's a couple additional benefits to our solution. One is that by leveraging the SIM card to validate the device identification and authenticate that device, it introduces no new hardware to your solution. Any device that's going to use a cellular network is already going to use a SIM card, and so we are leveraging that SIM card to provide the device authentication. Works with any type of device, any type of cellular technology. Another thing that we do is we can also pre-configure that with your cloud credentials to automatically provision both the cellular network connectivity and the back-end cloud service simultaneously. So, and that's really where the zero-touch provisioning name comes from. When used that way, by configuring the credentials up front, the SIM card that you then receive will make it so that a single activation step coming off the manufacturing line provisions both the cellular connectivity as well as the cloud connectivity simultaneously. So another added benefit to make this solution a bit more scalable, but this is our approach to device identity and solving those device identity vulnerability challenges, is to provide a secure SIM element that manages that authentication for that device. Now, next, we're going to jump into data access vulnerability and what some of the options are to protect the data that the device is going to be sending. And so one of the areas that a lot of solution deployers have looked at before, solution builders, is they focused on protecting the data access at the device level and in trying to prevent hacks at the device level that then would steal that data or use that data to, or use that device to attack, like the Mirai botnet example and so forth. And one option is to put the device in kiosk mode. Basically, turn that device into a single application device where it will, theoretically only serve one purpose. This is relatively easy to do and scalable and low cost. It is really just a program that's running at the device itself. But because it's running at the device itself, that means that if the device is hacked, it can still be weaponized, or the data can still be stolen from the device itself. This also introduces operating system requirements on the device where it needs to be able to support this type of mode, this type of program. Not every IoT device is built with the horsepower or the room or the space to be able to support this type of implementation. The next option that a lot of people have looked at is to implement a firewall on the device. And while this is certainly more secure than kiosk mode, that device is still physically hackable. And what I mean by that is the device is still going to be out in the field. If you give someone enough time with that device physically in their hands, they will be able to work around that firewall. And implementing the firewall does come with a high development effort and a high cost, which can be a challenge. And so one of the ways that we've addressed the data access vulnerability is to protect the data at the network level. And so what we've built is what we call our ConnectionLock solution, where basically at the cellular network level, we are able to whitelist and blacklist IP endpoints, where what our customers will do is tell us which endpoints they want their devices to communicate with. We will whitelist those endpoints and automatically blacklist everything else. And so this does a couple things. First and foremost is that it is basically zero effort on your end or our customer's end, the solution builder's end, to configure this. All they need to do is tell us the endpoints that they want to send their devices to, and we will whitelist those and then take care of the rest automatically. The other thing that it does is it does prevent the negative impacts of a physical device hack. And so obviously, while these devices are out in the field, if you give someone enough time, like I had mentioned with the firewall, they will be able to physically hack around any safeguards that are at the device itself. While nobody can guarantee that will never happen, what our solution does is that even if a device is hacked, it will restrict that device sending data to anywhere else. This, for example, would have prevented the Mirai botnet attack because the devices, even if hacked, would not be able to reach out to other parties, other websites, other places. They can still only communicate back to those endpoints that they were designed to communicate with. And again, because it's controlled at the network level, this bypasses those concerns. And so again, the key points there are by protecting the device at the network level, not only is it a bit more secure, but it's also no work up front to get that configured, no additional development, no additional costs up front to configure this type of solution. It's all taken care of on the back end by our intelligent network. So then the last bucket of requirements we want to talk around is around the zero-day vulnerability. Now, it's not enough in the gist of this is it's not enough to just create security measures and put them in place ahead of time. We live in a much more dynamic world where you need to be able to address any security concerns that happen, be able to fix issues remotely, fix issues for devices that are out in the field. And so the common approach to that would be to be able to send a remote update, an OTA over-the-air security patch down to the device, where a breach is detected, where something needs to be sent down to patch up that breach. You would be sending that down to the device in the form of a firmware update or whatever else it might be, a security patch that needs to be sent down to the device. And so when we look at some of the regulations that are coming out, this capability is a requirement. And so what we want to focus on today is not how to go about creating a program to send an update. What we want to talk about are some of the challenges that you are going to face when trying to send updates over these new IoT networks like LTE-M and NB-IoT that are inherently designed for low bandwidth. Now, one of the, obviously with these low bandwidth networks, only so much data can be sent to and from the device at any given time, and they are throttled and they have network limitations in terms of how much data they can send. For most IoT devices, this is not going, the limitations of LTE-M, for example, the low bandwidth nature of it is not going to impact the day-to-day communication of that device. It's only when you need to send down large bits of information, and specifically sending information down to the device, there will be lots of constraints. And another issue with LTE-M that perhaps wasn't thought about enough ahead of time, or as people started to deploy the first devices on LTE-M, but there are far more significant cell tower congestion issues with LTE-M, and far different than with LTE or even other technologies where the majority of that cell tower was specifically for that technology. LTE-M is just a piece of that, and so it can really only support so many devices communicating with that tower at any given time. Now, ultimately, what these congestion and bandwidth limitations are doing are creating an environment where if you need to send down an update to devices, it's going to be very, very challenging to do so because of the bandwidth and congestion issues. If you have, for example, dozens of your devices talking to the same cell tower and you need to send down an update to all of them, even if there weren't any other devices from any other deployment talking to that same cell tower, which there probably are, you would still experience congestion issues just from your own activity. And obviously then multiply that by the number of other devices that will be talking to that same cell tower, you're going to have a high failure rate when you try to push down updates to those devices. And obviously with high failure rates come high costs of retries, tracking those retries, figuring out which devices have been updated, have not been updated. When we put that in the context of the zero-day vulnerability and fixing security patches as quick as possible, that becomes a huge challenge, largely because of the time and tracking which devices are going to be ready for an update, which ones accepted the update, and which ones failed. Tracking all of that is going to be a pretty big nightmare, especially as you get into the tens of thousands of devices, and it's going to have a very, very high operational cost. So with that challenge in mind, some of the options that people have looked at to address that challenge, the first is to create homegrown processes and tools. Now, obviously one option is using things like manual spreadsheets to track devices that have accepted the update or not. That is very, very difficult to do, especially at scale. So how can you create your own processes and tools that can help automate that at scale? If you go do that and develop those tools, which certainly, if you have the team in place to do it, then that's certainly an option. And it allows you to customize those update capabilities exactly to your needs and how you are going to use those updates. But it comes with a high development cost and effort. Everything from not just the people and the teams that are going to be required to build it and run it, but the time it's going to take for those teams to do that. The other thing it might do is it might limit scalability depending on how you build it and how large you plan on your deployment being and how, the tools and processes you create. How many devices does it allow you to track and send updates to? Largely up to your control if you do build it, but again, that comes with a very, very high price tag from a people and time perspective. The other option is to look at third parties to get management software and scheduling software. The pros there, obviously, it's built for you. You don't have to go through the effort to develop and launch. And it can be completely automated, but assuming you have all the right pieces. For example, not every OTA management software is going to work with every type of device. Not every OTA management software is going to have the right type of network connectivity awareness. And not every type of software is going to work seamlessly with your application. So there's a lot of puzzle pieces to put together there. And because of that, there's no guarantee that everything is going to work the way that you want it to. The other downside to this option is that it can be costly. Paying somebody else to do something for you also carries a significant price tag. So we're about to jump into the how we go about looking at addressing this challenge. But before we do, I believe we have our last poll question.
Yes, Evan, we do. It's just coming up on screen now. And the question is, how do you manage remote updates today? And the options are with homegrown software, using manual tools or processes such as spreadsheets, using third-party software and or tools, and not applicable because you don't execute remote updates today. So the question is, how do you manage remote updates today? And the options are homegrown software, manual tools or processes, third-party software and or tools, and not applicable because you don't execute remote updates today. And I'm just waiting for the responses to settle down. And it looks like there's a relatively even spread between homegrown software and third-party software and tools, which I guess is encouraging because manual tools and processes will have real problems when handling the scale of future IoT. I suppose of more concern is the lack of execution of remote updates today. However, it does seem that the vast majority of people are using software-based solutions to manage their remote updates. So I guess that is a less of a cause of concern. Evan, what are your views?
Mm-hmm. No, and I think that's about what I expected. From the standpoint of majority of those who have addressed it are looking at homegrown solutions or third-party tools. Surprised that do not execute remote updates is as high as it is, but that probably for a couple different reasons. But looking at the two winners, I think that's about right. And I think that when we look at our next topic, our solution to it, it actually might add some value to both categories. So
okay, let's get on and do that then. Let's close the poll and move on.
Okay,
great.
So
thanks.
Yep, thank you, George. So when we look at how we go about addressing, the zero-day solution or providing additional capabilities and tools to make sending down updates more efficient, faster, and more scalable, we do it by providing a connectivity-aware campaign manager. And so really what that means is that we have all the network visibility to know exactly when a device is online, when it's ready for an update. We can work with people to figure out when their devices are most prime and most ready for that update, and then apply management software to scheduling these campaigns to track, automatically send the updates to the devices that are ready based on their network connection status. Track the results, track which devices, went through successfully, which ones didn't, and then automate the retries. And so by providing that management, logic, as part of this software program, but really matching that up against the connectivity state awareness, that is ultimately what increases the success rates of managing or sending down these updates. And so by leveraging that, not just the network connection status, but also the device location, we can see, which devices are all communicating to the same cell tower. We can track, where we're likely to see congestion or not. Ultimately, what we do is we help you, and even if you have your own homegrown solution, tying in this connectivity state awareness into your solution will only help you do a better job of sending down these updates in a more efficient way. And so we've built this solution really designed to increase the efficiency and scalability of executing these updates. and reducing the retry cost, not just from a tracking and management and operational standpoint, but by also limiting the amount of retries and then therefore limiting the amount of transportation costs that are wasted by some of these retries and sending down an update that only gets halfway consumed and so forth. And so our smart OTA management, our smart remote update management software is really meant to take the network information that we have, use it to help identify which devices are ready for the update, and then help automate the execution of that campaign and the retries of that campaign to get your entire fleet of devices updated with that security patch, for example, as quick as possible and at low cost as possible to you. So leveraging the connectivity awareness is really where we focus to help solve this issue, which obviously for LTM and then even going forward into NB-IoT is going to be a very large operational challenge. All right, so we want to get to your questions, and so just to do a quick recap of what I covered today, device identity vulnerability, obviously, all three of these are increasingly important topics to consider, and really you don't have much of a choice anymore. You have to address these. So our ZTP, our zero-touch provisioning solution, which uses a secure SIM element to handle the device authentication, helps you do that automatically as part of our connectivity offering. When we look at the data access vulnerability, our ConnectionLock solution, which restricts devices to communicate only with certain back-end endpoints, helps protect devices from attacks and helps protect the data that the devices are sending. And then lastly, when we look at the zero-day vulnerability and the processes that need to be in place to manage updates, our smart OTA management solution helps you use connectivity awareness to streamline those updates, track the progress, and automate the retries to help get those sent through faster. So if you want to learn more information about how we can help you, please reach out to us, and we'd be happy to take a look at what your needs are and how we can help you solve some of these security challenges. So with that, I'm going to toss it back to George, and we'll get to some of your questions.
That's great. Thank you, Evan. Really nice presentation, really informative. The first question we've got in is, what are the legal repercussions of the new regulations? And I guess that's quite a wide question, but I'll put that initially to Robin to give Evan a chance to get his breath back. So, Robin, what are the repercussions?
Yeah, that's a good idea. Yes. Legal repercussions. I mean, there are lots of repercussions or potential repercussions. I mean, Evan sort of mentioned the brand issue, which is obviously not a legal issue, but the opportunity or potential for destroying the brand if you get it wrong, and there is an attack. There's also this whole point about government agencies being prohibited from acquiring non-compliant devices. So there is a potential for significant business limitation if those regulations are not adhered to. And then, if a product is contrary to the regulations and does get into the marketplace, then there are legal implications. Now, the SB 327, California's law or extension of the law, that's subject to legal interpretation at this stage. So it's an enforcement or a potential enforcement from the California Attorney General and local officials. So there is a potential action or court action that could be taken. Obviously, there's potential fines for non-compliance. In the case of GDPR in Europe, there is a huge potential fine. It tends to be a percentage of total revenue. So there are lots of measures that could be taken that are not particularly nice.
Yeah, that's a massive repercussion.
Yeah, so I think that there are a lot of different flavors to this. It's not just legal repercussions. It's the chance that you might not be able to sell anything if you don't actually conform to it. Then, if you do sell it, do manage to sell it, you might be liable to a legal action anyway. So there are all sorts of levels of this that could take effect.
Great, thanks, Robin. I've got a question now, which is definitely going to be one for Evan or possibly Amit. What benefits does your ConnectionLock have over a VPN? Is the question.
Yeah, and that's a great question. And so when we look at protecting device data access or data at the network level, a VPN is a very common way to do it. And when we look at the security benefits of each, they both do a great job of protecting the data as it's being sent through the network. I think the big difference between ConnectionLock versus our ConnectionLock solution versus a standard VPN setup is really the ease of implementation and the lack of setup needed on the solution builder's end. And so, especially as we look at much more complex cloud architecture deployments and multiple different endpoints, multiple cloud instances, potentially even still multiple different data centers that need to be set up with the VPN connection, that can be a growing in a tricky set of VPNs to get set up, because there's multiple parties that need to be involved to get them set up and configured and so forth. The beauty of our ConnectionLock solution is that really the only setup required is to tell us which endpoints to whitelist, and then we automatically block the rest. And there's no additional infrastructure setup, no additional tunnels that need to be set up and so forth. So it's a much lower effort to get up and launched when compared to a traditional VPN.
Great, thanks, Evan. Next question that's coming is, will there be the same OTA network limitations on NB-IoT as you described for LTE-M?
Yeah, and I can take a first stab at this one, and then Robin, please feel free to chime in. But really, when we look at NB-IoT, it's only going to get worse. It's an even lower bandwidth network, even lower throughput capabilities, and even more restrictions around the updates that are going to be able to be sent down to those devices at any given time. And so when we look at these IoT networks, especially the cellular-based IoT networks, certainly moving towards a direction of lower bandwidth for IoT as opposed to higher bandwidth for IoT. And so the problems around managing these updates are only going to get worse and worse. One, as we get into more NB-IoT deployments, especially, but also as the collective LTE-M deployments and collective NB-IoT deployments grow, and the more devices there are out there, they're all going to be competing for the same cell towers. And so this problem, unfortunately, is probably only going to get worse and worse.
Great, thank you. Robin, do you have anything to add on that?
No, I think that is the major point, actually, that as we get more restricted bandwidth, and we don't necessarily have more restricted size of patches to go down them, then the difficulty of downloading those becomes more intense. And if there are more items out there to download to, then clearly the situation gets potentially much worse. So it does need to be automated. It can't be done manually, and so there needs to be a system in place that can manage different devices to be updated at different times, keeps a track of which ones are updated and not updated, and so forth. So it has to be done to a plan.
Great, thanks, Robin. That leads quite nicely into the next question, actually, which is there a special risk for NB-IoT compared to Cellular or Sigfox or others, or is it all the same risk level, regardless of network type? I'll put that to anyone who wants to answer it.
Sure,
yeah, you can
go first, Robin,
yeah.
if you'd like. Yep, okay. So I think that when we look at LTE-M and NB-IoT being, networks based on cellular architecture and infrastructure, they're going to be inherently a bit more secure than some of the other LPWA technologies out there. And so I think that, from that perspective, there's maybe a bit more comfortability with the levels of security with those two. But I think that, these challenges are going to exist with any type of wireless connection. Where that device is going to be somewhere that's not physically, right in front of you or visible or reachable to you. These concerns are all going to be there. So those are just kind of my 2 cents. But Robin, I'll let you chime in.
No, again, I would agree very much with that. That the lower the bandwidth that's available, the more potential there is for difficulty. If the patches are very small and can be managed to be very small, like in machine code and stuff like that, then you can overcome some of these difficulties. But that requires significant planning and pre-processing to be able to do that. And then again, you've got that against the need for rapid updates. So if there is a hack, for example, and there is a need to respond to that quickly to secure a large number of devices, then that's obviously puts stress on the system to try and deal with that. I think with the other technologies, you mentioned LoRa and Sigfox, for example. There are also issues with those. I think that they have different ways of dealing with those, but there's still not necessarily the same sort of issue of being able to update rapidly or as rapidly as possible. So that is the main issue, and that's going to be the main issue moving forward. Is how to manage that process. It's no longer sufficient just to have those devices out there. They've got to be managed on an ongoing basis as well. That's really, of course, what Evan's been talking about.
Okay, thanks, Robin. Got a question for Evan or Amit now, which is, does your zero-day solution work on devices that do not have GPS capabilities?
Okay, yeah, and so I think that as I was going through that, I'd mentioned providing the location information to kind of combat some of the network congestion challenges that might be there. And so, in short, no, we do not need the device to have GPS capabilities. We can see through our network, which cell towers that the devices are talking to, and be able to map according to that. So no, that solution does not require anything on the device's end, whether it be GPS or other. And we can provide that location information, general location information, because of the where that device is registering on which cell tower and so forth, but does not require GPS. So good question, good clarification.
Okay, great. Moving on then. I've had this is quite an interesting question, I think. The question is, with many device and sensor manufacturers embedding AI chips, do you see this as a positive in regards to device security, as long as the AI is transparent and not black box AI? So do you see the embedding of AI being a positive factor here? And I'll ask that to, I guess, Robin to begin with.
I guess it could be positive, but it could be adding a lot of cost as well. These are not necessarily cheap things to include, so you're unlikely to add that to small sensors and smaller devices. It's more likely that you would add that to much larger connected assets, and then it's a question of, well, what do you need to do in those that's going to be improve the security. I think that there is potential for AI in those kinds of situations, but I think that the implementation, the cost, and the keeping that up to date and so forth is not necessarily going to add a great deal of value. So there needs to be a balance struck there.
Great, thanks, Robin. Evan, do you have any observations on the embedding of AI chips?
No, I think I agree with Robin's thoughts on that, and especially since we are right at the top of the hour. I think probably AI is something we could do a whole other webinar topic on, but no, yeah, I agree with Robin's inputs, and so thank you for that.
Right, I'm afraid we are out of time. There are several more questions from the audience, but we'll have to answer those offline. So I'd like to take the opportunity to thank today's speakers, Evan Whitelock, Amit Ketawat, and Robin Duke-Woolley from Beecham Research. I'd like to also thank the audience for your stimulating questions and your participation in today's event, and I look forward to welcoming you all to another IoT webinar soon. Thanks again, and goodbye.